Hello everybody. This video is about section 4.2, relative extreme points. So first, the first paragraph talks about the definition. A relative extreme point, f of c, is a point on a function f where a relative maximum or relative minimum occurs. So from this one, we know relative extreme point has two possibilities, maximum or relative minimum. And for a relative extreme point, you have to include the full parts, f of c. So that means you have to say point 2, f of 2. Suppose this point is a point c. So you can say point c is a relative extreme point. Or you can say 2, f of 2 is a relative extreme point. But you cannot just use one part of it. You just say, all right, the 2, not just c, 2 is a relative maximum point. Or you cannot say f of 2 is a relative extreme point. That is not correct. You have to include both parts, f of c. And next part, since we talk about relative extreme point, two possibilities, relative maximum or relative minimum point, then let's see what is a relative maximum point. The first one, a function has a relative maximum at input c. So here, a relative extreme point, we have c and f of c. So from here, you can see the second part, f of c, is called a relative maximum value. All right, then let's go back to the definition. A function has a relative maximum at input c if the output f of c is greater than or equal to. So here we have the first condition for the relative extreme point. For the relative maximum point, that is, of course, this point, f of c, must be greater than or equal to any other point in this open interval. So the first key point is f of c the function value must be greater than any other points. And the second part is pay attention to in some open interval around c. So for a relative maximum point, first one, greater than or equal to any other point. The second one, the interval is open interval around c. So what does this mean? For example, from here we know point c is, of course, a relative maximum point. Then let's check this condition. First, f of c is greater than or equal to any other points around c in an open interval. So that means actually if you use any open interval from here, for example, and then the corresponding point function value is here and here. So it's less than the relative maximum point f of c. So alright, this condition are satisfied. The two conditions in any open interval around c, and the second one, f of c is the biggest number. So this is the definition for the relative maximum. Why do I have to mention about the open interval? Later you're gonna see why. And similar, a relative minimum point is this is the first condition, less than or equal to, and the second condition similar in some open interval around c. And then the corresponding output value is referred to as a relative minimum. And then similar, the first one, f of c, is the relative maximum point. Relative maximum value. And then next, let's try example 1. So example 1, pause the video and do it by yourself. So for example 1, the first point A. Point A, let's check point A to see if it is a relative maximum or relative minimum by using the conditions. Remember the conditions 2 greater than or equal to in some open interval, in any open interval around the point. So let's check first point A. Point A, if we draw any open interval, for example, this one, we cannot compare f of A We cannot compare the corresponding output value at point A and the other points in this open interval because point A is already the boundary. If A is the boundary, then the left side is out of the interval. So that means we cannot compare it. So that means even though the first condition, the blue one, the first condition is satisfied, it's greater than or equal to, it's okay because this one you can see here, this is the maximum point. It's greater than any other point. But the second condition does not satisfy. The second condition is some open interval. For this one, we cannot draw any open interval because point A is the boundary point. So A is neither. It's not a relative maximum point. It's not a relative minimum point. It's neither. And then let's check point B. Point B, the first condition. If we draw any open interval covers B, then you can see, all right, the corresponding function value f of B is the maximum. So we know, f of B is the relative minimum. It's the minimum because this is the negative function. So we know point B is relative minimum. And for point B, let's check the slope of the tangent line. If you draw a tangent line, then you can see the tangent line is horizontal. So the slope of the tangent line is 0. And similar, point C. Point C, if you draw any open interval, then this is the corresponding function. And you can see point f of C is the maximum. So this point is relative maximum. And similar, if you draw a tangent line, then you can see it's a horizontal tangent line, so the slope is 0. And point D is a relative minimum. Point E is a relative maximum. And the corresponding slope is all 0. And then next, let's check the last point G. Actually, point G is similar to point A. This is the boundary point. For a boundary point, that means you cannot get any open interval around G or around A. So that means the two conditions of the relative maximum point or relative minimum point are not satisfied because we cannot get an open interval. So for point A and point G, neither of them, relative maximum or relative minimum, are satisfied. Question B, what is the slope of the function at each of the relative extreme points? So B, C, D, E, we have 4 relative extreme points, and the corresponding slope are just 0. So the conclusion is just a 0. So we haven't finished the last part. Okay, if a function f of x is defined on a closed interval. So pay attention, for a closed interval, that means the two boundary points, point A and point B, is there. This is A and this is B. It is a closed interval. That means we can get the corresponding function value f of A and f of B. But for an open interval, for example, this is an open interval. For this open interval, the function f is not defined at point A or point B because this is an open interval. That means A is not part of our domain. But for a closed interval, the second part, this is a closed interval. That means the two boundaries A and B are actually in our domain. But for the open interval, A and B are not. So you can see here, this is a closed interval, A and B. And this is a function defined on a closed interval, A to B. Then in this function, f of A, this is f of B. In this function, a relative extreme point does not occur at the two ends points, A and B. That is because we cannot draw an open interval here. So we cannot use the relative maximum or relative minimum definition to check if the two end points A and B, if they are relative maximums or relative minimums. So this is a very important paragraph. You have to memorize it. That means for a closed interval, the two end point A and B both of them cannot be relative maximum or relative minimums, the two boundary points. So if you memorize that one, then these two questions are easy. You don't have to check it. You just see, all right, this is a boundary point. This is the end point A. So it cannot be relative extreme point. And similar, G is the end point. So G cannot be relative extreme point. The next critical point. So this is the second new definition in this section. The first one, remember, the first one is a relative extreme point, and the second one is the critical point. So what is a critical point? A critical point is a function f. A critical point of a function f is actually a number c. So is it this one is a number c? In the domain of f, where f prime of c is 0 or f prime of c does not exist. So we have two cases. This is the first one and this is the second one. And let's go over. We just learned if a point is a relative extreme point, then the corresponding derivative must be 0. And this is the critical point. For a critical point, two possibilities is either s of c equals to 0 or f prime of c does not exist. So if you are given a function graph and ask you how many critical points, you just can't, you just check how many of them have horizontal tangent line. That means the derivative is 0. In the second case is a little bit more complicated. A derivative does not exist. We say a derivative does not exist. Three cases. And the first one is a derivative does not exist. The first possibility is the function has a vertical tangent line. If the function has a vertical tangent line, then the derivative does not exist. For example, point C. So the first function has a vertical tangent line. And the second case, the function has a sharp corner. And like this one, a sharp corner, then the function, the derivative does not exist. And the last case is the function is not continuous. So for example, in this point. So you can see that means point C, the function is not even defined at point C. So we cannot say the function f prime of c exists. So three cases for does not exist. The function has a vertical tangent line, the function has a sharp corner, and the function has a is not continuous. For all the three cases, we say the function f prime of c does not exist. In other words, this special point c is actually the critical point. And the other case of critical point is the derivative is 0. So the function has a horizontal tangent line. These are the critical points possibilities. And the next shows you a critical point identifies the location of all possible relative extreme points. So what does this mean? We know a relative extreme points. A relative extreme points, relative maximum or relative minimum point. If we know this point is a relative maximum or relative minimum point, then we know the corresponding derivative must be 0. But if we know f prime of c is 0, it does not mean that the function has a relative maximum or relative minimum. So you can see here, this is not an if and only if condition. So we can go only from relative maximum, relative minimum to f prime of c is 0. But here for a critical point, as long as f prime of c is 0, then we just say it's critical point. So from here you can see the critical point shows you all the possibilities of relative extreme point. If we use the graph, then this is the critical point. critical points has two cases, so a proper subset will be f prime of c is 0. And the relative extreme point. Relative extreme point is just one of the possibilities. So actually, you can see if it is a relative extreme point, it must be a critical point. Critical point are not just the relative extreme points. So you can see the relation. And the next one is about the very important test, the first derivative test. And all right, I'm sorry, we haven't finished the last part. If a function has a relative maximum or relative minimum point at c, and f prime of c exists, so you can see two conditions. The first one, point c, the function has a relative extreme point, relative extreme value at point c, and the second one, the corresponding derivative exists. Then f prime of c is 0. So you can see in this direction, all right, so this shows you if f prime of c does not exist, then f prime of c is not necessary to be 0. And this one, if the derivative is 0, this is not necessarily an extreme point at point c. So that is the second one. For a relative maximum or relative minimum point, its derivative is not necessary to be 0. Later, we will see more examples. And for the first derivative test, we use the first derivative test to determine whether a relative extreme point occurs at a critical point. So this is why we use the first derivative test to determine. Now we have a lot of relative extreme points. So, we have a lot of critical points, and we want to pick up the relative extreme points from the critical points. So if you are given a function graph, so the first step will be, okay, how many critical points in this function graph? Highlight all of the critical points. And suppose we have 10 critical points. Step number 2, how many of them are relative extreme points? In order to answer the second question, the second step, we have to use the first derivative test. Then let's see what it is. For a critical point c of a function f that is continuous on some open interval around c. The first one, if f prime, so you can see here, all of them, actually, we are talking about f prime of x. If f prime changes from positive to negative as x increases through c, then the function f has a relative maximum at point c. Let's see why. So the derivative changes from positive to negative. Positive, if the derivative is positive, means the function f is actually increasing. And then to negative, that means from that special point, the function is decreasing. So we can see, all right, this special point c is actually a relative maximum point. Then f, you can see the conclusion, then the function has a relative maximum at point c, from positive to negative. And similar, the next one, if the function changes from negative to positive, changes from negative to positive, if the function derivative is negative, that means the function is decreasing. If the function is positive, that means the function is increasing. So this point c is actually a relative minimum point. And the last case is, what if the f prime is a constant function? That means the sign does not change. If the derivative does not change sign, has two possibilities. The first one, f prime of x is a constant function. And the second possibility, even though it's not a constant function, but the sign is always positive, like this one. So it's still the f prime does not change sign. And in this case, we just say the function f does not have a relative extreme point. So all of them are talking about based on the critical points. We need to check which critical point is relative extreme point. Then we use the first derivative test. So first, let's finish example 2. So for example 2, if you don't have your textbook, then this is the full part of example 2. Example 2, all right. The first one, we are given the function f of x and the function graph. So the first one, identify the critical points on the function graph f of x by marking an x on the point. So we know the critical points, 2 possibilities. The derivative does not exist. Second one, the derivative is 0. So for this one, the derivative is the derivative f prime of x exists on all the interval, but we have a point that the derivative is 0. This one, and this point is about 2.5. And the question B, write the equation whose solutions identify the critical points. So what does this mean? That means we know f prime of x is from here we know it is 8.x minus 2, and we wanna ask what is the value of x when we have f prime of x equals to 0. So that means f prime of x equals to 0. That means 0.8x minus 2 is 0. So solve for this one. You don't have to use your calculator. This is a trivial. And C, solve for the equation. So we know the point is just solve for this equation is just a 2.5. And the question D, draw the slope of the function graph f of x and verify that the slope graph crosses the x-axis at the critical point C. So this is from the last chapter. So make sure that your point 2.5, the derivative f prime of 2.5 must be 0. Then the rest part will be. And then question E. When x is less than point, this is point C. This is point C. So for this one, f prime is positive or negative when x is less than C in this part. So this part is negative and the other part is positive. So the first one is negative and the second one is the positive. So for this one, let's go back to relative maximum and relative minimum. For the relative minimum, if the f prime changes from negative to positive, then it is a minimum. So let's see this one. From negative to positive, so this is a relative minimum point. Relative minimum. So next, please finish example 3. Pause the video here. The first one, this is the function graph that is given, and ask you which one or highlight all the critical points. So this one, the derivative exists all the time, so we only looking for the case, we only looking for the value C that f prime of C is 0. So for this one, we have only 1 point. That is, let's say 0.1. So you can see in this point, if you draw a tangent line, it's horizontal. So the derivative is 0. That means f prime of C is 0. And the question B, draw the slope graph. The slope graph, pay attention, the function is decreasing all the time. So that means the derivative must be negative all the time. And the critical point, the derivative is 0. So the slope graph will be like this one. And the question C, does the slope graph cross the x-axis at the point critical point C? Does this point, this is the special point? Actually, no. Because this one, the slope graph just touches this axis, but actually does not cross this one. This is a cross, but the blue one is just a touches. And the question D, f prime of x, when x is less than c is negative, when x is greater than c negative, so it's actually from negative to negative. That means the sign of f prime of x does not change. So it does not change. Right here, if f prime of x does not change, the sign does not change. So it's not a relative maximum or relative minimum. So just say no. And then after we finish example, let's go back to the last part of the box, graphically. So the first derivative test shows you the theory part, and the next one, talking about the graphically. What does the first derivative test mean? And this one is about a continuous case, and the second part is about a not continuous, discontinuous case. And then let's see, graphically, the first derivative test says that for a function that is continuous on an open interval, first one, for the function that is continuous on an open interval around c, and with f prime of c is 0. So that means, all right, now we know point c is one of the critical points. Then let's check it. Let's check if point c is a relative extreme point. So you can see the keyword is the derivative graph. If the slope graph crosses, not just touches the input axis, the input axis at x equals to c, then this point there's a relative extreme point or relative. We say this is a relative extreme point. So what does this mean? It means for a critical point c, if the corresponding derivative graph crosses the x-axis, not just touches it, then this point is a critical. Then this point is a relative extreme point. And for a function that is continuous, if f prime of c does not exist, for a function that is continuous on an open interval around c, with this derivative does not exist. For this case, if the slope graph is on opposite of the input x-axis at point c, then there is a relative extreme point. So you can see this is the second case that f prime of c does not exist. And the last part is about the not continuous case. If a function is not continuous at the point c, then if it is not continuous, then of course f prime of c does not exist. Then we just examine so if the f prime of c does not exist, this is the second case of the critical points. We have two cases of the critical points. The derivative does not exist, and the derivative is 0. So two possibilities: 0, derivative is 0, or derivative does not exist. And so this one talks about the second case of the critical points, because the basic idea of the first derivative test is to test whether a critical point is a relative extreme point. That means we just pick a random critical point and use our derivative test to test if it is a relative extreme point. And the critical points, we have two possibilities: derivative is 0 or derivative does not exist. So for this one, we just examine the graph of f to determine whether it is. So you just check the graph. So actually, this is an example. So you can see here, This is an example shows you what does that mean, that the derivative touches the x-axis. This is the one that just touches. If it touches, then that is not a relative extreme point. Because from here, from the function graph, you can see this is decreasing all the time, especially this point. It's not a relative extreme point. So next, let's finish example 4. So for example 4, the first question, in this function graph, how many critical points? The answer is 3. We have 3 critical points. And let's see, the first critical point occurs at point 3. Because this point is the first critical point because it has a horizontal tangent line. And then if the function is continuous at this point, then let's check this derivative graph. The derivative graph when x is less than 3. That means on the left branch of this one. The derivative, the slope graph is positive because the function is increasing. It's positive. And similar when x is greater than 3. The slope is negative. The left part, because the function is increasing, so the derivative is positive. The right part, the function is decreasing, so the derivative is negative. And in this case, by using the first derivative test, then we know the derivative has a relative maximum point. The function f, relative maximum point at x equals to 3. And this is our first critical point. That is a relative maximum point. And then let's see, what about the second critical point? So this is the second critical point. Why? Because this one has a sharp corner. For a function, for example, a function has a sharp corner at point C, then we just say the f prime of C does not exist. And this is the second case of the critical point. The derivative does not exist. And then let's check this point. Check the point B. Point B, the left part of the function is decreasing, so the derivative is negative. And the second part of B, the right side of point B is also decreasing. So that means actually both sides, the derivative is negative. Also negative. So actually that means the sign of the derivative does not change. So that means the slope does not exist. Oh, that means this point is not a relative extreme point. Not a relative extreme point. And then the third critical point, this is the first critical point A, the second critical point, and this is the third critical point C, because the function does not exist. The derivative does not exist. The function exists, but the derivative does not exist. And this is point 10. So this, we know this is a critical point. Next, let's check if this critical point is a relative extreme point by using the first derivative test. Then you can see the left part. The left part is decreasing. That means the derivative is negative. The right part is increasing. That means the derivative is positive. So actually, the sign changes. So this is a relative minimum point. And the homework for this one is example 5 and example 6. So still similar, just send me the pictures. And please also, you can see the page 105 and page 106. We have this one shows you 2 ways to get the corresponding relative maximum and relative minimum points in your calculator. So first, send me the picture of example 5, the written part, and also send me a picture of this one. So you can just follow these steps. 1, 2, 3, 4, 5, 6, and just send me the result. Like I wanna see the maximum and this minimum. And this one, this is the second method. So also please show me this graph. And example 6. So these are the homeworks. Alright, thanks for watching.